Hello everyone. So today is day 3 of DSA preparation. So the five problems I solved today was, the first one is kth ancestor in a tree. The second is maximum sum for non-adjacent nodes. The third is binary tree from in-order and post-order. Fourth is binary tree from in-order and pre-order. And the fifth one is burning tree. So let's move to the first problem, the kth ancestor in a tree. It was uh, almost similar to the least common ancestor problem. So here we made up like vector path and then we use recursion, and when we find the right path, we just calculated, like it was asking, like there was a k, there was a, what is ask a node k, great. Kth ancestor. Last time we was least common ancestor, and there is kth ancestor. So once we have got the vector like the path, then we can move from backward position and easily get the kth part like this. Great. So this was basically maximum sum of non-adjacent side. So this was a bit difficult, tricky problem. I couldn't solve it. I had to take help. So basically, it was solved using help of recursion. So basically, this is the method I use. Simple. Define the pair, return max. It is not. Basically, for each node, there was a pair defined, first and second. For the first included uh, the max sum till that level, including that node, and the second was excluding that node. So here the pair, we have the pair. So basically the in the pair, first was basically uh, including that root node, and the second was excluding that root node, and the sum maximum at that level. So basically, if you want to find a pair at 4, it will be including the 4, maximum at that side is 4, and if you are excluding, it will be 0. And if you go for 2, if you are including 2, then it will be 2 comma, and if you are excluding 2, it will be 4, 2 comma 4. So like this, we are defining a pair at each node, and for the pair, they were pair basically contain two numbers, first and the second. The first was the maximum up to that level, including that node, and second was including and excluding a maximum up to that height. And this is basically creating binary tree from in-order and pre-order. So basically the few things we need to remind, like no was like in the pre-order, the first one is the root node. So we use that concept, and also another concept that, like in order, let's say here in here 4 is the root node we have found. So basically 3 and 1 will lie in the left tree, and 0 to 5 will lie in the uh, right tree. So these two concepts were basically used, and I also created a map like to define the position. It's a bit lengthy problem, but the basic concept you need to remember is this one. Let's solve this problem very easier. Take an example. We have the in order, we have the pre-order. Okay, so the pre-order is given from the first leftmost, like first index, 0th index of the pre-order, let's say is 1. So we can say the 1 will be the root node. Okay, so we have checked 1 is the root node. Now check where the 1 lies in the in order. Okay, 1 lies in the at the starting position. There is no left value, so the entire tree will be the right. So we can say 687 will lie in the right, as we can see in the graph. Okay, so now we have to think of 687. Now see pre-order, we forget 1, remaining is 6 7 8. So now the root will be 6. So here the root is 6, and look for 6 in the in order. Here is also 6 at the starting, so there is no left, only right. So there are two choices, 7 and 8. Now we look for pre-order. So in this way we proceed. Basically look for the leftmost element of the preorder. We have to do the root, and now look, after we found that element, let's say here is a 1, look for 1 in order. So if there is 1, the leftmost, the element left to it will be left tree, element right to it will be right tree. uh, a similar situation is for the post order. In the post order, but the rightmost part becomes the root node, and the in order concept becomes the same. And while using recursion, we have to define like we have to use uh, right part first and then the left part. It goes on with the basics. When we go through the basics, then there won't be a problem. This was very challenging. I couldn't also solve this problem. This was the burning tree. So basically, the method to solve it, basically it divided the problem into 3 parts, like creating a node parent map, finding the target, like for target like here let's say it is the target, and then after that burning the tree. So for creating the node parent map, so create, so for each node, this was the method. Yes, so basically it use level or traversal. We have defined queue, and we for each, when we are traversing, we have created a map, and this was the simple part. Great. And here when we found that data like target, and we have returned the target. Great. And this was the burning part. Once we know the target, we have the mapping. We also created queue. This is also like level or traversal. Creating flag. It was very difficult. Like it took me a lot of time. I also copied the code from Loveber. I have related this one. Great. So these 5 problems are what which I solved today. Today was the difficult, like the questions I took, like creating binary tree from pre-order, post-order, and the in-order one, and the burning tree, and this one max some of non-distance nodes. Like they were difficult and take a lot of time. Almost I couldn't solve them. I had to take help. Okay, so that's it for today. Let's meet another day. Bye bye.